Today we are going to derive the lens maker's formula. As the name suggests, this is a formula used to make lenses. There are mainly different types of lenses, and the main type are biconvex, both sides are convex, biconcave, both sides are concave, and plano concave, where one side is plane, etc. And usually this biconvex lens, we usually call it convex lens, and this one concave lens. Now let us see what is this lens maker's formula. This formula is called the lens maker's formula. That is 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. F stands for focal length of a given lens. N stands for refractive index of the medium of the lens. Usually lenses are made of glass. So material of the glass. And R1 and R2 stands for, as usual, R, the radius of curvature. Since lens has got two faces, R1 is the radius of curvature of the first face, R2 that of the second face. To derive the lens maker's formula, we use the equation n2 by v minus n1 by u equals n2 minus n1 by r. I hope you remember this formula which we have already derived. N2 second medium, n1 refractive index of first medium, v image distance, u object distance, and r radius of curvature. Where do we use this equation? This equation we applied when an object is placed in front of a surface, a curved surface separating two media of different refractive index. We use this formula. This is the object distance u, this is the image distance v. N1 and N2 refractive indices of the two media respectively, and r the radius of curvature. Now to derive the lens maker's formula, we consider this lens made of two sides, two surfaces. Okay? And we consider or split this as two cases. Actually, we know that when an object is placed in front of a lens, light ray passes through it like this. The two light rays, after passing through this, meets at a point and you get the image here. But we are going to split this as two cases. First case, for this surface, the light ray passing through this surface and this object, first an image is formed. Okay, this is the first case, and let us call that image I dash. So this is the first surface of the lens. Okay, and this I dash acts as an object for the second, imaginary object for the second surface. So this I dash acts as an imaginary object for the second surface of the lens, and the final image I is formed. So we are considering this as two steps. Okay, actually this is the process. When an object is placed in front of a lens, you get an image. This process we are going to split as two steps. One for this surface, one for the other surface. Okay. So the first image formed by the first surface, we call it I dash. And let this distance, image distance, we call it as v dash. And this I dash acts as the object for the second surface. And the final image I is formed. So let us move on to the derivation of the lens maker's formula. Consider this diagram for the lens maker's formula derivation. As I told you, this is a lens, an object placed in front of the lens. First you get an image I dash. This acts as object for the second phase, and the final image I is formed. So we have two phases for the lens. ABC is the first phase, ADC is the second phase. And we are going to use the formula n2 by v minus n1 by u equals n2 minus n1 by r for the two phases. So let us apply this formula for the first phase A, B, C. So applying the equation for the first phase, what is the formula? N2 by V minus N1 by U equals N2 minus N1 by R. So for the first phase ABC, which is the first medium, refractive index N1. Second medium has got refractive index N2. So for this phase, first refractive index is N1, second refractive index is N2. Object distance is U and the first image formed is I dash. And the image distance is V dash. So let us apply the formula N2 by V minus N1 by U equals N2 minus N1 by R for the phase ABC. N2 by V. V stands for the image distance. Here for phase ABC, the image distance is V dash minus N1 by U. N1 by U is the same thing. First phase object distance, same thing, is equal to N2 minus N1 by R1. What is R1? It is the radius of curvature of the first phase. Usually the formula is N2 minus N1 by R. Here we are applying R1 because there are two phases. For the first phase, we will put R1. For the second phase, we will put R2. Now let us apply the same formula for the phase ADC. For the second phase ADC, let us apply the same formula. N2 by V minus N1 by U equals N2 minus N1 by R. What is N2 and N1 here? For the second phase, N2 and N1 gets replaced. For the first medium, it is N2 and for the second medium, it is N1. So we have to interchange N1 and N2 in our formula. And what about the image distance and the object distance? Object distance becomes V dash and image distance becomes V. So these are the changes that we are going to apply in the formula N2 by V minus N1 by U equals N2 minus N1 by R. So applying the new terms, instead of N2, we are substituting N1 because N2 and N1 is replacing. Instead of N1, I put N2. Here also N2 and N1 gets replaced. And instead of R, since this is the second phase ADC, we are going to put R2. And what about object distance and image distance? N2 by V. V becomes final distance, image distance V itself. N1 by U, what about the object distance? Object, I told you, it is the first one. First image becomes object for the second phase. ആദ്യത്തെ image ആണ് imaginary object for the second phase. So, instead of U, I am going to put V dash. And here it becomes N1 minus N2. So I am going to rewrite N1 minus N2 as I am taking the minus outside and it becomes minus of N2 minus N1. Let us call this as equation number 2. And the first one as equation number 1. So we have got two equations. Look at the equations very carefully. Do we see any like terms? Because we are going to add the two equations 1 and 2. What are the like terms? You can see if you look carefully in both the equations 1 and 2, there are two same terms, N2 by V dash. So when you add the two equations, you can cancel N2 by V dash. Because in equation 1 and equation 2, when you are adding, one is positive, one is negative. Plus and minus, same terms gets cancelled. And what is remaining? N1 by V minus N1 by U equals, again you have the common N2 minus N1 is common. We can take that common outside, and what is remaining? You get the next step. When you add the two equations 1 and 2, you get N1 by V minus N1 by U equals N2 minus N1 is common, and what is remaining? 1 by R1 minus 1 by R2. Okay. Next step, again N1 is common here. I am taking N1 outside. N1 outside the bracket, you get 1 by V minus 1 by U equals N2 minus N1 into 1 by R1 minus 1 by R2. Now we are going to use a specific condition in this part. Instead of V and U, we have studied that when the object is at infinity, where do you get the image? When the object is at infinity, we get the image at the focus. When the object is at infinity, we get the image at the focus. So what about 1 by V and 1 by U? 1 by V becomes, instead of V, it becomes F. And what about 1 by U? 1 by infinity is 0. So 1 by U is 0 because 1 by infinity is 0. 1 by V becomes 1 by F when you apply this case. So substituting these values, N1 into 1 by F minus 0 is equal to the right side. N1 into 1 by F, V becomes F, I told you. Minus 1 by U, this part becomes 0, gets cancelled because 1 by infinity is 0. So what remains? N1 by F is equal to N2 minus N1 into 1 by R1 minus 1 by R2. Now this N1, I am going to bring it cross dividing or dividing both sides by N1. Here it becomes 1 and this N1 comes to the denominator here. So I am going to divide both sides by N1. N1 by F, when you divide by N1, what happens? This becomes 1 by F, that is 1 by F. This side also I am going to divide by N1, so you can get this. And the right side remains. And so what you get? 1 by F is equal to N2 minus N1 by N1 into the remaining part. Now again I am going to divide these two terms separately. N2 by N1 minus N1 by N1. N1, I am going to divide both the terms by N1. So N2 by N1 minus N1 by N1 into 1 by R1 minus 1 by R2. Now we have already studied N2 by N1 is N21. N1 by N1, 1. So you get the equation 1 by F is equal to, this was our required equation or the lens maker's formula. Or in general, instead of N21, you can write like this also, where N stands for refractive index of the material of the lens. Usually, refractive index of glass, we consider with glass with respect to air. N21, refractive index of second medium with respect to first medium. Here, the lens is made of glass, so glass with respect to air. And this is called the lens maker's formula. And how can we make lenses with this formula? If you know the refractive index of the glass and if you want to make a particular lens with a particular focal length, suppose we want to make a lens of focal length 20 centimeter and you know the refractive index of glass is 1.5. So you can decide the radius of curvature and cut the glass accordingly. So you will get the lens of the required focal length. While deriving the lens maker's formula, we had used this step to replace 1 by V minus 1 by U. So instead of 1 by V minus 1 by U, what did we write? N1 into, instead of this one, we wrote N1 into 1 by F. So that is the equation for focal length of a lens. So we get the lens formula as 1 by V minus 1 by U equals 1 by F. I hope you remember our mirror equation. What was the difference? Mirror equation was 1 by V plus 1 by U equals 1 by F. Compare with lens equation, mirror equation. And again, magnification of a lens is given by M is equal to HI by HO. Height of image by height of object is equal to V by U. Compare that with our mirror magnification. HI by HO is equal to minus V by U. Okay. So just compare the lens formulas and the mirror formulas. Lens formula is 1 by V minus 1 by U equals 1 by F, while the mirror equation is 1 by V plus 1 by U equals 1 by F. So what is the difference? Mirror equation it is plus and lens equation it is minus. Same formula but here it is minus. And same thing, magnification for a lens it is positive and for the mirror it is negative. Now image construction of the lens is same as the case of mirror, concave mirror, convex mirror, which we have already studied. So I want you to refer figure 9.19.